Okay, welcome back. Did you take a second to try to recalculate these numbers? Let's do it together. Isn't that exciting? I love it when we have to discover a little mistake in there. It's super fun. It just keeps you on your toes. All right, so we had to put our moles in. So let's go ahead and add moles to our delta H. Let's add moles to our delta S. And then let's go ahead and add moles to our delta G, and then let's recalculate and let's write those numbers in green. How is that? So sometimes in this class, you have to just stop at the end and just kind of ask yourself, wait, does that make sense? So I'm going to do that first one, and this time I am getting a negative 57.24. I'm going to go ahead and add my units, kilojoules. Okay, now, if I had remembered that this was kilojoule per mole and I needed to cancel the moles, that might have reminded me to add my moles. All right, let's try our delta S again. Okay, 304 minus 240 times our moles. This time I'm getting a negative 176. Holy crap, that changes everything, doesn't it? Now that is in joules over Kelvin. So that means that this isn't towards more freedom at all. This is not favored because of the negative. Oh, moles matter. What? All right, and now in our delta G, let's see if that changes everything. Let's take our 97.82 minus, and now I'm getting a minus 4.78. So now there's a minus sign. That means this is spontaneous. I love it. Okay, doesn't that changes everything. So this is one of the most common mistakes that we have on this test is to forget our moles. Look at what that did to our calculation. I love it. So this is now spontaneous. Okay, now I'm going to go ahead and add a page. So I need to just flip to get my keyboard to pop up here for just a second. I just lost everything. I need to get my keyboard so that I can add a page. I don't know why my iPad is freaking out on me. I just really want to add a page. How do I get there's my keyboard. Okay, I'm going to add a few pages. Okay, so now let's sass it up, and then we're actually done with new material for this unit. So I'm going to sass this up. We just solved this whole problem at 298K. Well, shut the front door. We're not always at room temperature. Well, what if we change the temperature and we try this reaction at, I'm just going to make up something, 510 Kelvin. Okay, now we've got two things we need to keep in mind. Here is where that temperature comes in. Our temperature is going to change our entropy. So there are two equations for Gibbs free energy. That first one is if you're at room temperature, products minus reactants. The second one is that we need to include, if we have a different temperature, we are going to use our table. So in fact, I'm not at standard temperature here, so I shouldn't really have that little knot there. But I am going to use the values from the tables for my entropy and my enthalpy. I need to compare both of those terms and include the fact that temperature is going to change our entropy. So put a big sparkle pen box around this one. This is going to be our new equation for our Gibbs free energy at anything other than 298K. So how do you use this equation then? Well, we can actually plug in our values from the tables for both of these And then what we're including is that new temperature. So let's go ahead and calculate this, all right? Our delta G then. All right, what did we get for our enthalpy? We got in our new value minus 57.24. Let's put that in. Okay, minus 57.24. I'm going to go ahead and include the units on this one. That is kilojoules. Minus our new temperature. Okay, times our entropy. That was our minus 176. Okay, but put in your units. That is joules over Kelvin. Okay, stop right here. Moles was our first common mistake. Units is our second common mistake. We cannot leave it like this. We have to then convert this to kilojoules. Either one. Okay, I'm going to go ahead and convert that to kilojoules. So that means divide by 1,000. And now I'm in kilojoules. There you go. Now we're talking turkey. All right, plug this in on your calculator, and now we can find out if this reaction is spontaneous at 510 Kelvin. Now, and then we're going to get deep for a second and try some of these problems in lecture. So I'm going to take 57, okay, minus 510 times, and I get a 32.52. Now double check that, and let's see if you get that as well. So what I'm getting here is minus a negative 89.76. Okay, I just wanted to double check because I'm using my iPhone, not a regular calculator, so sometimes that goes wonky on my negatives. So let's just double check. So what did we just do to that reaction? Is that reaction now a positive? So it is no longer spontaneous. So you can see that changing the temperature actually has a really big effect on whether or not something is spontaneous. Sometimes if you heat it up, you're making that reaction spontaneous. Sometimes you heat it up and you're not making that reaction spontaneous. So we've got two sets of conditions you have to keep in mind. Your temperature with your Gibbs free energy. Okay, if you are at standard room temperature, you can do your products minus reactants. If you are at any other temperature, you have to use your Gibbs free energy equation. All right, so let's stop this video here and let you practice homework and various questions because there are a ton of these examples in our lecture. All right.